Okay, so these are the questions we are required to solve. We need to balance the following nuclear equations. Now, before we do that, we need to establish some principles. If you understand these principles, you'll be able to work all these reactions or balance the equations by yourself. So the first thing you need to know is you need to know about the reactive particles that are there, and at least the ones that are actually needful to like that are most useful to balance chemical reactions, sorry, nuclear reactions with. Now the first one is the alpha particle. So the alpha particle is written this way. The symbol is actually like this, or written this way, because it has the same mass number as well as the atomic number as the helium atom. So you could well write the alpha particle as He. So the full nuclear symbol for an alpha particle is this way. You have it as 4 and 2. You could write it this way, or you could write it this other way. Now another one is actually the beta particle. So I think I'm just gonna write it like this. Now the beta particle could be written with this symbol or this symbol. This one is most relatable because that's actually the symbol for the beta particle, while this one is the symbol for an electron. But generally, beta particles would have a mass number of a 0, an atomic number of a -1. So this should be what should be here also. So I'm going to write it here. You're going to have 0 and that's 1. Now, this is the same thing. Now, aside beta particles, you also have another one that is called positrons. Now, positron is actually the positive form of a beta particle. Some reactions can only be balanced by the use of positrons. So positrons are written this way. You're going to have 0, E, and instead of a minus, you have a +1. So that goes the same way with the other symbol. So this is going to be +1. So that should be basically it. And the next one you have is the gamma particle. And the gamma particle or the gamma ray is written as this. And that generally has a 0 number, mass number, and a 0 atomic number. So basically this is the representation for a gamma particle. Now you could also have another one that is called the neutron. So the neutron, I'm just gonna write it this way. You have a neutron, and neutrons are written this way. This is a neutron. Now there is also another one that is called a neutrino. Neutrinos are written this way. Yeah. Then you can also have anti-neutrinos. Now anti-neutrinos are written this way. Then you could also have mesons or pi mesons. Now you could have positive pi mesons and the negative one. So the positive pi mesons are these ones, and then the negative pi mesons, they are these ones. And then, yeah, we also need to find out what will be the elemental symbol for a proton. So I actually didn't write out what a proton looks like. So let us see that. That will be, in this way, 1 hydrogen. Now, there are nuclear reactions that can only be balanced by addition of protons. So this is basically it. Like, you actually have more than these ones, but the use of these ones basically would help you to balance nuclear equations. So with this, we're going to move back to these questions. So the first question here is this stuff that you see here. We actually have uranium reacted or bombarded with an alpha particle, and that leads to this stuff. So I think I need to wipe this out. Okay, so that's what you have. Now, let me take this also out. Now, if you wanted to solve this nuclear equation and find out what is the elemental symbol X, you first need to add all the numbers you have on the left hand side and compare it with the addition of the numbers on the right hand side. Now, when you do that, you'll be able to find out how much number of mass number or atomic number that is actually required to balance out everything. So for mass number, I'm just going to write that as an A because that is actually an A. Now you need to add this to this other one. So that gives us 242. So that is 242. Now for the atomic number, I'm going to write that as Z. That gives you 94. Now this is for the left hand side, right? So let's go to the right hand side. Now here we have 239 plus now this is a 3 that is multiplied with the neutron. Remember, a neutron is a radioactive particle, so we have 239 added to 3 multiplied by 1, so that gives us a 3. Now 239 plus a 3, that gives you 242. So on this side we have A being equal to 242 as well as you had it on this other side. Then you have a Z right here. This is 94. And this is 3 multiplied by 0. That gives you a 0. So if you added that to this, that would give you a 94. Now you need to understand that stuff which is on the left hand side must be exactly what should be on the right hand side. If not, it will not be called an equation. It is equivalent because stuff which is on the left hand side must be equal to stuff which is on the right hand side. Now, as you can see, 242, which is the value of the atomic number for the left hand side, happens to be exactly the same as what you have on the right hand side without having known what X is going to be. But that's actually a simple one. That doesn't mean that this stuff is actually useless or there isn't actually anything there. There is actually something here. Now, we know that for the mass number part of that molecule, there should be a 0 because you need to add a 0 to this in order to get what is on the other side. Now here also there is going to be a 0. So you can see that the atomic number of this molecule will be, well, that is not a molecule. This is an atom or a nuclide. So the atomic number of this nuclide, as we see from here, is a 0. And the mass number of the nuclide would also be a 0. So here you're going to have 0x and you have a 0x. Now remember what we said this is, right? This is the gamma particle. So this is what you should have there. So this is going to be a gamma particle. That is basically it. This will be the answer. Now let's go on to the next one. I need to wipe this out. So the next one, we had plutonium. So this is 4 plus 4, and then you have a 2 here. and then you have an X, or is it a Y? And this is 2, 1, 0, and an N. Now we need to find out what it is, Y. And so as usual, we have 2, 3, 9 added to 4. That gives you A equal to 2, 4, 3. Then here you have 94 plus 2. So Z would obviously be equal to 96. Now on this other side, we have A is equal to 240 added to 2 multiplied by 1. That gives you 242, right? So we need to find out what should be the value that adds up to give us this. Obviously, that should be a 1, right? Because if you took a 1 and added it to 242, that would give you 243. So here we should have a 1. That is going to be 1. Now for Z, this is 95 plus 2 multiplied by 0. That gives you a 0 added to 95. That gives you a 95. Now, obviously, this again will be added to a 1 because we know that that is the value to make up 96 on the left hand side. So you're looking at only for the symbol that carries this. So if we have 1, 1, and Y, what do you think is that symbol that carries a 1 as the mass number and as the atomic number? So that is a proton. That is 1, 1, and a hydrogen. This is what you have. Now, if you do not really want to write it this way, you could also write it this other way. This is 1, 1, and then you're going to have a P. This will be the same thing. So all these are actually equivalent to each other. So therefore, we know that this stuff, Y, is actually this. That is a proton. Now let us move straight up to the last one. So the third one is you have a 238, and that is uranium. And you have a nitrogen nuclide. And then you have a Y. Okay. Now, as usual, this is going to be 2, 3, 8 plus 14. Now, if we added that, that will give us a 2 here. And here we're going to have a 52. And then you're going to have a 2 here. Then you're going to have the atomic number, that is 92 plus 7. That is going to be 99. So that is for the left hand side. Now for the right hand side, the only thing we have is a 5 multiplied by 1. That gives us a 5. Now we need to take 5 away from this. Now if we did that, that should leave us with 247. So we need to add a 247. Now next up we have the atomic number. That is 5 multiplied by 0. That is a 0. So obviously we're going to have a 99 there. So this is 99. Yeah. So you're actually looking for that nuclide that has the atomic number 99 and also the mass number of 247. So what do you think that is going to be? If you have 247 of a Y and you have 99 here, what is that symbol? Now this is actually what we call Einsteinium. So I'm just gonna wipe some stuff out here. So this is a 247 and you got 99. that is what you have. This is Einsteinium. So that will be the answer to this one. So that is it.